So 60% of all global emissions are caused by energy and electricity production. And a key driver of decarbonization in these fields is batteries. Batteries are going to supercharge the decarbonization of the energy sector, whether it be with electric vehicles, electric cars, electric planes, electric trucks, or with solving renewable intermittency with long duration or short duration energy storage. But from working in this field for a while, I've realized that battery research is actually stagnating. And the reason why is because research and experimentation is costly and time consuming. And this is a problem because if you think about it, we have all these really ambitious goals for 2035 or 2050, where we want to decarbonize our whole planet and electrify our whole planet. But like, how is that going to happen if we have all these problems with experimentation and testing? Well, we can accelerate the experimentation of batteries with battery simulations. Battery simulations can save up to 25% of the cost of experimentation and manufacturing. But there's a problem here. And the problem is that current battery simulations only do one type of battery, which is the industry standard lithium ion batteries. And I have a really, really good story about this where I was working in an electrochemistry lab last year working on lithium ion batteries. And I went to my professor and I was like, hey, like I want to work on not just lithium ion, but just like new gen type batteries, like, solid state batteries or redox flow batteries. And my professor was like, well, we don't really have like the money or the resources for all of those types of batteries, but how about you try simulations? So I looked around and I looked at different simulations, and turns out there's not actually simulations that do like batteries outside of lithium ion batteries. So there's not many resources for that. And why this is important is because different types of batteries have different optimization and performances, which can help us decarbonize different sectors of the energy industry. And to give you an idea how big this problem is, CATL, the biggest battery manufacturer in the world, wants to go from lithium ion batteries to sodium ion batteries. So sodium ion batteries are a huge player in the battery space and one of the biggest next gen batteries. But for every one research paper on sodium ion battery like simulations, there's about 20 to 25 research papers on lithium ion battery simulations because lithium ion batteries actually have resources and platforms to simulate the batteries. So we're thinking of producing a platform that simulates any kind of battery. Input any materials, we'll test how they would work and how the battery would work, and then apply them to parameters like SOC, which is state of charge, or C rate, or energy density, power density, so you can experiment without the lab. And so how this would work is for different parameters like energy density or power density, we would look at different research areas and different data, and we would use different AI models and algorithms to output different different results for different parameters. Then we would accumulate all this into an ensemble, and then we would use graphs and all that to show how your battery is actually performing. But instead of showing you all the theory and all that boring stuff, let's actually show you the prototype that we built to show you how we would actually build this system. So here you have the anode, the cathode, and the electrolyte, and you can input what you want your anode and cathode to be. Then you also have your battery materials. So do you want to use sodium ion batteries? Do you want to use tin? Do you want to use all these different materials? How do you want your battery to be composed? Then you have your parameters. Is it your C rate, your volumetric energy density, your gravimetric energy density, and then your applications. Do you want to use this for energy storage, short duration or long duration? Or do you want to use this for electric vehicles like, electric planes or electric cars and things like that? Then here you can see, okay, how is your battery actually performing? Here's the energy density, the cost, the power density. Here's the discharge curve. How is your battery cell actually discharging? And here's your voltage curve. Like, how is it actually producing voltage? And then here you can actually go from battery cell to battery pack being an ensemble of battery cells. So what we mainly would do is go to researchers and sell our product and go from researcher to researcher and industry professionals to get their data, simulate the types of batteries they want to work on, and then accelerate their research. And I even talked to my PhD student about this, and she said that she would definitely use this, as well as most battery researchers are dying to look for something like this. And so, to give you an idea of how big this industry is, the battery industry is worth about $100 billion right now. And by 2030, it's expected to grow to $400 billion. So, not only is it important to decarbonize the planet, but also this growing sector needs a bunch of tools that aren't built yet. And so, we want to build the tools and the next simulation tools to build a future where innovation can be accelerated, where you can go from 10 months of experimentation and costly research to 10 seconds of simulations. Thank you.